Hi everyone, Mr. Rowe here. Just checking in. I thought I would, I've been experimenting with these screen capture video lessons, so I thought I would try it out. And, I've given you all the notes and the completed notes, but maybe sometimes it's good to see me work through some examples, hear my voice, talk through it, and also I can tell you what to really focus on and what maybe we can brush over just to pinpoint the key stuff we're going to be looking at. So the lesson I decided to do this with was the rational exponents lesson. So we haven't had too much contact since the last assessment, but the idea was that you would be putting in the work for this unit. So hopefully you've had a look at it. It's not very long, exponential relations, and there will be an assessment probably early next week, another assignment. So you want to make sure, hopefully you've been keeping up with the day-to-day work, looking at the homework, resources, etc. So this one I'm going to go through with you, and hopefully it provides some value for you. Alright, so rational exponents. The word rational means fraction, and exponents are exponents. So basically we're looking at fraction exponents. So you see all the examples down here. We're also going to see some negative exponents. So there was a review of exponent laws in the last lesson. Everything would have been reviewed from grade 9 except for negative exponents. But we're going to see negative exponents here, so I'll fill you in on what's going on there. So basically, the exponent law for if you have base a to the power of 1 over n, it's the nth root of a. So we're used to seeing the square root of a. So if this n was 2, it's not written, it's just assumed it's the square root. But this value could be cube root, fourth root, fifth root. So if it was the cubed root, it's what times what times what, as opposed to the square root. So if we were looking at this, we'll see an example of that right here. If you want to do 25 to the power 1/2 without a calculator, using this formula, it would be the square root of 25. Now, and anytime it's the square root, we never write that 2. If that 2's not there, we just assume it's the square root. And of course, the square root of 25 is 5. Now, the base of this exponent is negative 25. So this question wants the square root of a, the base, which is negative 25. And what's going to happen here when you try to do this in your calculator? You're going to get an error because there's no two numbers that are going to equal a negative value. You cannot take the square root of a negative. So it does not exist. It does not exist. I will put D and E. Alright, the 8 to the power of 1 over 3, according to this formula, is the equivalent of the cubed root of 8. So what times what times what equals 8? So I could do this in my head, but if you can't, you're going to use your calculator and you're going to find a button. It's usually above your square root button, or it could be on my calculator. I'm looking at it right now. It's above the to the power button. I think most likely it's going to be above this button or this button. And mine looks like this. It's going to be the X. This is what's above the button. You're going to see something like this. So to put this in your calculator, you'd put in the 3. That would be the X value. Then you would push like second function. That would activate this. You would press that button to get this. And then you would press 8. And then you would hit the equal sign. So this is on your calculator, and the answer would be 2. 2 times 2 is 4, 4 times 2 is 8. So 2 times 2 times 2 is 8. Next, we want the cubed root. I'm going to try to move through this quickly. I want to keep the video relatively short so you watch the whole thing, but feel free to pause it, go back, skip, whatever you need to do. You get stuck on an example, just go find it in the video and so on. So we're taking the cubed root of a negative. So when we tried to take the square root of a negative, it did not exist because a number times itself cannot be negative. However, you can take the cubed root of a negative because negative 2 times negative 2 times negative 2 equals negative 8. So the cube root of negative 8 is negative 2. Negative 2 times itself 3 times. So if this is an even number, 2, 4, 6, you will not be able to take the root of a negative number. But if it's an odd number, 3, 5, 7, etc., you will be able to. Okay, so this is an exponent form because it's written with a base with an exponent. Radical form, this is radical form. When it's written with the radical, this is the radical. As you recall, we did radicals. So if I want to do 64 to the power of 1/2 in radical form, that equals this. Square root of 64, evaluate to 8. The 4th root of 16, I'm going to use my calculator. That's going to be 2. The cubed root of negative 125 is going to be negative 5. And now we have our first negative exponent. So this is what we're going to do. So notice the exponent here is negative. If you went through the lesson yesterday with the, or not yesterday, whenever you looked at it, the last lesson, you would have seen a negative exponent. So this is how we're going to deal with it. The general law is this. If you have a to the power of negative n, we'll say, this is going to be equivalent to 1 over the base, a. I did not change the base to the positive exponent. That is the law for negative exponents. Along the way, we're going to come up with some tricks to help deal with these as the situation presents itself, but this is it in general. So what is this saying then? If I have base negative 125 to the power of negative 1/3, this is equivalent to 1 over, notice how I'm not changing the base. It's negative 125. What does change is the negative exponent becomes positive. So it's now 1 over negative 125 to the power of positive 1 over 3. So if I do the cubed root, I guess I should still be over here because I haven't done radical form yet. If I do the cubed root now, negative 125, that's the radical form, I'm going to get 1 over negative 5, or negative 1/5. So we'll see some more examples with negative exponents on the next couple pages, I believe. Alright, well, that was all fine and good when the exponent fraction was 1 over, 1 over 2, 1 over 3, 1 over 4. But what happens when it's not 1 over? For example, 4 over 3, 2 over 3, 3 over 4, etc. Well, this is the law. And there's two versions of it. Personally, I kind of prefer this one, but you can use either one. So what this is saying is the denominator goes here and the numerator goes here. So if I want 8 to the power of 4 over 3, what I'm actually going to look for is the cubed root of 8. And I'm going to use this version of the formula where I calculate that first, all to the power of 4. So there's the radical form. To evaluate this, the cubed root of 8, 2 times 2 times 2, is going to be 2 to the power of 4, which equals 16. Now, had I used this version, I would have gone, this is the cubed root of 8 to the power of 4. So this is why I don't like this version, because now I got to go to the calculator here. 8 to the power of 4 is 4096. So now I want the cubed root 4096. Which I'm just confirming does equal 16. So if you're watching this video, stay tuned to the end. I'm just going to have a few general words. I haven't talked to you in so long. It's obviously strange for everyone to having to do this distance learning. I'm just going to have a few words of encouragement and some other things I want to say. So if you get bored halfway through this video, just maybe go to the end, the last couple minutes, and say a few things about going forward, what we're going to be doing and looking at. So anyway, I'll work through these quickly. This says, what is the cubed root of 5 squared? Well, that's not going to work out very nicely now, is it? So this might be an opportunity where we might want to use this version, where instead we go the cubed root of 5 squared. So it's going to equal the cubed root of 25. And then this will not be a whole number. The cubed root of 25 is going to be 2.92. The cubed root of 9 to the power of 1/3 is going to be the cubed root of 9 to the power of 1. And again, there's no whole number answer here, but the cubed root of 9 is about 2.08. Fourth root of 81 to the power of 3. So to calculate the fourth root of 81, I'm going to put in 4, shift, exponent button, fourth root of 81 equals, it's 3. 3 times 3 times 3 times 3 is 81. And then 3 cubed is 27. Alright, so let's go through a few of these. they're not too many. I'll try to get this under 20 minutes, and I'll work through some of these. So we have a negative exponent, 36 to the power of negative 1/2. So this is going to become 1 over, I am not changing the base. It's going to be 36 to the power of positive 1 over 2, which equals 1 over the square root of 36, which equals 1 over 6. The next one, this isn't too much different from the examples we did above. It's going to be the cubed root of negative 64, and because I'm taking the cubed root, I can take the cubed root of a negative, and you can put this in your calculator, and you will get negative 4. Now this one's a little bit different. So these two questions look very similar, but they're actually a little bit different. And the difference is the base. Because this negative 64 is in brackets, that means the base is negative 64. Whereas the base of this exponent is positive 64. BEDMAS says do the exponent first, and this negative would be done after the fact. Now, in this example, it's not going to affect the final answer, but it has the potential to. Maybe I'll show you an aside if there's time. But how you do this question is you would actually go negative cubed root of 64. You would take the cubed root of 64 first. You would do this first. So you would get negative, and then the cubed root of 64 is 4. So you would get the same answer. So maybe we'll see an example where the answer would not be the same. And if one doesn't come up, maybe I'll come back to it, but we'll see. Alright, so now, this is interesting. We have the base is a fraction as well. So we have a rational exponent with a rational base. And if you remember quotient, there's a couple ways to do this, but if you remember quotient law, the outside exponent gets applied to both the numerator and the denominator. For example, if I were doing 2/3 squared, how would I answer that? I would go 2 squared for the numerator over 3 squared for the denominator. So you apply that exponent to the top and the bottom. So if I were to do that here, and again we kind of have this negative hanging out in the middle, and as you know, I kind of like to put that in the numerator. So this would be 8. I'm going to apply this exponent to the numerator. And the denominator. And now I'm just going to evaluate these separately. So I'm going to have the cubed root of negative 8 squared divided by the cubed root of 27 squared. I'm going to leak into this question here. The cubed root of negative 8, negative 2 squared. And the cubed root of 27 is 3 squared. Negative 2 squared is 4. 3 squared is 9. So final answer. So I'll switch colors just so this thing doesn't get too jumbled up. But if I were doing E, I'm going to go, we have a negative exponent here. So I'm going to go 1 over, the base is 4. I did not change it, to the power of 3 over 2. So that's going to become the square root of 4. You could write the 2, you don't have to. But it's the square root of 2 to the power, square root of 4 to the power of 3. So that's going to equal square root of 4 is 2 to the power of 3 is 8. We'll go back to blue. Sorry about this watermark here. I'm on my laptop at home. All I have here is the basic version of Smart Notebook. So I'll move that out of the way. So here we have a negative exponent again. So this is going to be 1 over, notice I'm not changing the base. It's going to be negative 8. The only thing that changes is the negative exponent now becomes positive. So this is going to be the cubed root of negative 8. Put some brackets around that, all squared. Cubed root of negative 8 is negative 2. Square that, and you get positive 1 over 4. Alright, so moving on. So again, 4 examples left. Alright, so we'll see what we can do here. This is good because there's a couple of exponent laws here that we'll go over. So here we can use our power law. It says, or we could, there's multiple ways to do these, but if I were doing this question, I would use the power law where you keep the base and multiply the exponents. So if you have like a to the power of n, you have a base with an exponent to a higher power, you keep the base and you multiply the exponents, as you saw from the last lesson. So this would be keep the base, multiply these exponents is 10 over 4. And now I'm going to apply my rational exponents. This is going to be the 4th root of 144. So simplify using exponent laws first, then evaluate if possible. So I'm going to see if there is a 4th root of 144. There is not. So we could evaluate it still. I will go ahead and do that. It's going to be a decimal answer, or it's not, 248,000. So 4th root, 144. So if you put that in your calculator, you will get 248,832. Alright, next one. We have a negative exponent. So, and this is a power of a product. So there's a couple ways you can do this. You can use your power of a product rule, but personally I would get rid of this negative exponent first by going 1 over, do not change the base, to the power of 1/2. So this is a bit of a review from the last lesson on power of a product. I'll switch up the colors here. The base has more than one factor. It's not just, x to the power of 8 to the power of 1/2. It's 49. So the power of a product says if you have something like this to the power of m, we'll say, then you apply the outside exponent to all the factors in the base. That's what power of a product is. And that's what I'm going to do. So this is going to equal, I might run out of room here. It's going to be 49. It's supposed to be a 9 to the power of 1/2 x to the power of 8 to the power of 1/2. And then I'm just going to do those separately. So I'm out of room, so I'm just going to go down here. Actually, I'll come off to the side here. So this is going to be 1 over square root 49 to the power of 1. And now I'm going to use my power law. Keep the base, multiply the exponents. So it's going to be x to the power of 8 over 2. So final answer, square root of 49 is 7. X, 8 divided by 2 is 4. So over here, again, so this is just another power of a product, and it's not a negative exponent. So I'm just going to go ahead and apply this outside exponent to all the 3 factors in the base. So this is going to become 27 to the power of 2 over 3. A cubed to the power of 2 over 3, and then b to the power of 6. So I took each one of those individual factors in the base and applied the outside exponent 2/3. So for this is going to be the cubed root of 27 to the power of 2. And for these, I'm just going to use my power law, keep the base the same, multiply the exponents. So top times top, 3 times 2 is 6. Bottom times bottom, 3 times 1 is 3. So base b, 6 times 2, multiply those numerators, 6 over 1. So it's going to be this. Cubed root of 27 is 3 squared. We get a to the power of 2, b to the power of 4. So finally, 3 squared, And then final answer is 9 a squared b to the power 4. So the video is getting kind of long, so I don't think we have to worry about this one. There is a shortcut we could take. We're not gonna worry about it. If you're interested, there will be a final solution on the posted completed notes. So going forward, all the notes, all the blank notes, all the completed notes, all the textbook, everything's already online. So I'm just going to be posting updates, maybe just reminding you to continue, make sure you're keeping up with the day-to-day. They kind of expect you to put in 3 hours a week, so clearly we wouldn't be able to finish the whole course doing that. So again, we will be kind of picking and choosing our topics. There will be a couple units that we might not even get to. I'm just going to make sure that you have the big ideas that are going to help you next year if you take 4U functions. That being said, all I'm expecting from you is your best effort. So keep up, attempt the homework. Don't get overwhelmed by leaving everything to the last minute. When I give those assignments, there'll be a few days to work on it, so don't waste time. Don't leave it to the last minute. I can see the submission times, and some of you are leaving it right to the wire, so don't put any unnecessary stress on yourself, and just try your best. That's really all we're asking here. Don't stress out too much. Like anything you don't pick up and you're like, oh, I'm worried, I don't know this for next year. Next year's going to look a lot different too. Math teachers in general, we're all going to have to fill gaps, so we're all going to be prepared for that. So don't even be worrying about things like that right now. Just be worrying about putting in your best effort, and be sure to contact me as needed. But because everything's already posted, like I won't be updating being like, oh yeah, new lessons are up, because they're already up. So there's a lot of responsibility on you. But maybe every 3-4 days I'll put an update, maybe make sure you're up to this point, assessment coming in a few days kind of thing. So for this unit, I think it's been about 8 days since our assessment, so make sure that you're working through all of the lessons for this unit. Most of this stuff is going to be relevant if you take 4U functions, and then there will be an assignment probably posted on Monday with a few days I'll give you to submit it. So God bless anyone who's able to submit the document in one file. If you rewatch that video on how to do that, that would make life a lot easier. But as long as I get it, if I have to download 7 different files, that's fine. Just make sure you get the assessments to me, and if something's going on and I need to hear about it, I just don't not hand an assignment and me not hear from you. Let me know what's going on. I'll do my best to help. And again, we're all in this together, and hopefully things get back to normal soon. But if not, everyone's going to do the best they can. So take care of yourself, and I'll try to post a couple of these for some of the more important concepts going forward. So check the website every day for updates. Bye for now.